there, grade 9 math learners. For this video, we're going to discuss how to graph quadratic function. I want you to sit back and relax and prepare your ballpen and your notebook in taking down notes. Steps in graphing quadratic function. Step 1. Determine the opening of the parabola. In determining the parabola, remember to check the value of a. If it is positive, then it opens upward, and if it's negative, then it opens downward. Second step, determine the vertex. If the given function is in general form y equals ax squared plus bx plus c, in determining the vertex, you'll be needing the formula h equals negative b over 2a and k equals 4ac minus b squared all over 4a. If the given function is in vertex form y equals a x minus h squared plus k, determining the vertex is easier because you'll just get the values of h and k. Step 3. Find the axis of symmetry. You can find the axis of symmetry by simply getting the x, because x equals h. Give the x-intercepts. Just substitute y equals 0, then you can have the value of x-intercept. Remember, these are the roots of the function or the zeros of the function. Give the y-intercepts. Just substitute x equals 0, then you can have the value of y-intercept, 0, y. Step 6. Present the table of values. Create the value of tables by filling in the value of axis of symmetry and coordinates of vertex, x-intercepts, and y-intercept. As you can see on the table, you will put in the center of the table of values the axis of symmetry, and the x-intercept and the vertex, then the y-intercept. Take note that you need to have at least 5 points in your table of values. For the domain, continue writing the values of your domain. The value of x are arranged consecutively. For the range, solve for the value of y by using the values of x and use substitution. Sketch the graph. Place and label the x and y axis. Plot the points and label the coordinates found in the table of values, including the x and y intercepts. Connect the points and create the parabola. Don't forget the arrowheads at the end of the parabola. Label everything, including the vertex, minimum or maximum point, and x and y intercepts. Determine the minimum or the maximum point. That would be the last step. The minimum point or the maximum point is the vertex of the parabola. So for you to understand better, class, how to graph a parabola or how to graph the quadratic function, then let's proceed to the examples. For you to understand better how to graph quadratic functions, let's have example number 1. So for example number 1, y equals x squared minus 4x plus 4, we're going to find the following. Opening of the parabola, vertex, axis of symmetry, x-intercept, y-intercept, table of values, graph on minimum or maximum point. So let's have first the opening of the parabola. Since our given quadratic function is y equals x squared minus 4x plus 4, we will just need to identify our a. Our a here equals to 1, and since 1 is greater than 0, therefore, the parabola opens upward. And if you can see here, for instance, that our a is -1, for example, so -1 is lesser than 0, so that means the parabola opens downward. Okay, next would be we need to find the vertex. Okay, in finding the vertex class, we need to use the HK formula. Okay, but before that, we need to identify first our A, B, and C. Our A here is 1, our B is -4, and our C is 4. And the formula for H is -B over 2A, and the formula for K is 4AC minus B squared over 4A. H equals negative, and our B is -4 over 2 times 1. And here, negative times -4, that is +4 over 2, and our H is 2. Next, we're going to solve for the K. K equals 4, substitute 1 to A. Our C is 4 and our B is -4. Squared over 4 times 1. Next, K, that's 4 times 1 times 4, that is 16, minus -4 squared, that is also 16, over 4, and this is 0 over 4, and that would be K is equal to 0. Therefore, class, here, our vertex, I will change the color to be emphasized, our vertex here is 2, 0. Next, we're going to solve for the axis of symmetry. Our axis of symmetry is very easy to find because we're just going to get or find the value of H, because axis of symmetry, the formula for this is X equals H. X stands for the axis of symmetry, meaning this is the place where our graph will turn, the turning point of our graph. So X equals H, and our H is 2. Therefore, our axis of symmetry is 2. Next, let's have the x-intercept. For the x-intercept, we need to let y be equal to 0. So getting the formula or getting the given y equals x squared minus 4x plus 4, we will let y be equal to 0. Change y to 0 equals x squared minus 4x plus 4. And this is so familiar to us, class, because we already discussed this one. In getting the values of x in this equation, we will just use any of the method: extracting square root, factoring, completing the square, quadratic formula. In this case, for me, my method that I will choose will be factoring. So I will factor this one, and this would be x, and this is minus. What are the factors of 4 that you're going to add? The answer is 4, so that would be 2 and 2. Therefore, x minus 2 equals 0. By factoring property, minus 2 equals 0, so x equals 2 and x equals 2. Since they are equal, we will just write x-intercept. Our x-intercept is 2, and box that one. There are some instances, class, that your x-intercept will be 2. There will be 2 x-intercepts. Therefore, you'll just write 2 values here. Okay, next, we're going to have the y-intercept. For y-intercept, we're just going to let x be equal to 0. So in the given quadratic function, y equals x squared minus 4x plus 4, we will substitute 0 to all x. So it will become 0 squared minus 4x. 0 squared minus 4 times 0 plus 4. Therefore, it will become y equals 0 squared is 0 minus 4 times 0 is 0. So directly y equals to 4. Therefore, our y-intercept here is 4. And I want you to box that one. Next, we will have the table of values. F, our table of values. For our table of values, we want to see 5 values there, class. So, we will use the horizontal table of values. Okay. 1, 2, 3, 4, 5. And you will find the center of your table, which is in this part. You will put here the vertex. Okay. And our vertex is, we will go back. Oh, here, since our vertex is 2, 0, we will put here, we will put 2, 0 on the center. Okay, and for the remaining domain or the remaining values of x, we will follow the consecutive order. So this will be 3, this will be 4, this will be 1, and this would be 0. And we will solve for those. So our y is 4 if our x is 0. Next, we will have f if x equals to 1. So y equals x squared minus 4x plus 4. Substitute 1 to our x, it will become 1 squared minus 4 times 1 plus 4. Y equals 1 squared is 1 minus 4 plus 4. Therefore, our y, this would be cancelled already, so our y is 1. Therefore, our y is 1 if our x is 1. Next would be if our x equals to 3. So, y equals x squared minus 4x plus 4. Change x to 3, so 3 squared minus 4 times 3 plus 4. Y equals 9 minus 12 plus 4. So what is our answer here? So 9 minus 12, that is negative 3 plus 4. So negative 3 plus 4 is positive 1. So, therefore, our y is 1 if our x is 3. So, put it again on the table of values. So, for the next part, if x equals to 4, so copy the equation y equals x squared minus 4x plus 4. Substitute 4 to all x, so it will become 4 squared minus 4 times 4 plus 4. Then it will become y equals 16 minus 16 plus 4. So it will become 16 minus 16 is 0 plus 4, and our answer is 4. Therefore, our y is 4 if our x is 4. So we'll put 4 here to complete now our table of values. So our next step, we're going to graph. And using our table of values, it is easier for us to graph now our parabola. I will change now the color of my pen. Graph now, plot the points. 0, 4. 0, 4 is in this part, and I want you to label it properly, 0, 4. Next, 1, 1. Our 1, 1 is in this part, and label it properly, 1, 1. Next, 2, 0. 2, 0 is in this part, label it properly, 2, 0. Next, 3, 1. 3, 1 is in this part, label afterwards. And next, 4, 4. 4, 4 is here, so label 4, 4. Now the next step, class, you're going to graph now, or you're going to connect now the points. So this would be the parabola. Okay, make sure that you are turning it now in a curve. Connect the points like this, and don't forget to put arrowheads. Arrowheads in each end of the parabola. The meaning of arrowheads, class, that this parabola is continuous. And last step, we're going to find or identify the minimum or the maximum point. So, for letter H, the minimum or maximum point here, since our parabola opens downward, there's no maximum point and it only has minimum point. Therefore, our minimum point is 2, 0. And box now your final answer. That would be all for example number 1. Number 2. Y equals negative 2 x minus 1 squared. X minus 1 squared, and it's on the vertex form. It's on the vertex form. It's already in the vertex form, which is y equals a x minus h squared plus k. So your a here for the opening of the parabola, you can identify that your a is equal to negative 2. And negative 2 is less than 0, meaning the opening of the parabola, meaning the parabola opens downward. It opens downward because our a is less than 0. For our vertex, which is y equals negative 2x x minus 1 squared, it is easier for us, class, to identify the vertex because the given quadratic function is already in the vertex form. Therefore, we'll just identify the h, and the h here is 1, while our k is 0. Why 0? Because there's no plus here, so meaning there's nothing. So if there's nothing, the answer is 0. So our vertex is 1, 0. And I want you to put that inside the box. Next, for our axis of symmetry, it's very easy for us because it just equal to h, and our h is 1. Therefore, our axis of symmetry is 1. Next, for the x-intercept. For the x-intercept, class, we're just going to solve for the roots of the quadratic function. So we will let y be equal to 0. 0 equals to negative 2x minus 1 squared. And we will transform that one in this form so that it will be easier for us. And we were going to recall our knowledge in finding the roots of quadratic equation. We could choose any of the methods from completing the square, factoring, extracting square root, quadratic formula. It's up to you what method are you going to use and what method is convenient to you. So for me, in this one, I will use the extracting square root. So I will divide the whole equation with negative 2 so that negative 2 will be cancelled here. So it will become x minus 1 squared equals 0. Extract now the square root and it will become x minus 1 equals 0. Therefore, transpose negative 1 to the other side, it will become x equals 1. The x-intercept, the x-intercept is 1, 0. And I want you to highlight that answer. The x-intercept is 1, 0. Of course, there are some instances that your x-intercept will be 2, so x-intercepts. Next would be the y-intercept. For y-intercept, we need to let our x becomes 0. So we'll copy the given y equals negative 2 x minus 1 squared y equals negative 2. Substitute 0 to x, so 0 minus 1 squared. Y equals negative 2, negative 1 squared. Y equals to negative 2 times 1, and y is negative 2. Therefore, our y-intercept class is 0, negative 2. And that would be the answer for y-intercept. Next, we're going to move on to the table of values. Of course, I've said to the example number 1, as much as possible, we want to see at least 5 values here. Okay? So after putting or constructing the table of values, we will put the vertex in the center of the table. Next, fill in the domain or the x values consecutively, like 2, 3, negative 1, and 0. So I have a hint for you, class. Since the nature of our graph is parabola, therefore they are symmetrical, or our parabola is symmetrical. Therefore, this point 0 and 2 has the same value of y, and negative 1 and 3 has the same value of y. Okay, so for now, we're going to solve negative 1 and okay. If x equals to negative 1, so use the formula y equals to negative 2 x minus 1 squared, so it will become y equals to negative 2 negative 1 minus 1 squared. Y equals to negative 2 times negative 2 squared, so y equals to negative 2 negative 2 squared is 4, and y equals to negative 8. And put now negative 8 to the table of values here. Next, if 0 and 2 has the same values of y, so we could put it here negative 2, and we could put negative 8 for 3. But for us to check, we will solve. Okay, if x is 2, so y equals to negative 2 x minus 1 squared, that would be negative 2 minus 1 squared. Y equals to negative 2 minus 1 is 1 squared, and y is negative 2 and is negative 2. Now what if x is equals to 3? So y negative 2 3 minus 1 squared, y equals to negative 2 3 minus 1 is 2 squared. So y equals to negative 2 times 4, and that would be negative 8. So we already have the graph here. So with the help of our table of values, which we solved earlier, we could now graph the given points. So we will start with negative 1, negative 8. So negative 1, negative 8 is in this part. Negative 1, negative 8. I want you to label it properly. Negative 1, negative 8. Next, 0, negative 2. So 0, negative 2, it's in this part. I want you to label it properly. 0, negative 2. Next, 1, 0. 1, 0 is in this part. Label it 1, 0. 2, negative 2. So in this part, 2, negative 2. Lastly, 3, negative 8. So 3, negative 8 is in this part. So 3, negative 8. After plotting all the points, we will connect now the points together. So please bear with my drawing. So this is how it looks like. And don't forget to put arrowheads at the end point or at each parabola, and the points each of the parabola are arrowheads. That indicates that the parabola is continuous. Okay? Next, we're going to have the minimum or determine the minimum or the maximum point. Therefore, since our parabola opens downward, there's only a maximum point. So the maximum point is this one, the vertex. So our maximum point, we'll write it here. Maximum point is 1, 0. And that would be the end of the second example. For example number 3, y equals negative x squared plus 9. So for today class, we're going to have y equals negative x squared plus 9. And as we can see there, it is already either in the general form or in the vertex form. But we could say here that it is already in the vertex form, and we could identify that its a is equal to negative 1. And since negative 1 is lesser than 0, therefore the parabola opens downward. Okay, the parabola opens downward now. Now let's move on to the vertex. So let's have here y equals to negative x squared plus 9, and our a is negative 1. There's no b. Our b is 0. Our c is 9. Okay, so you will use the HK formula for your own convenience. H equals to negative b over 2a, and h equals to negative 0 over 2 times 1, and that is 0. And our k equals to 4ac minus b squared over 4a. So substitute k equals to 4 times 1 times 9 minus 0 over 4 times 1. So it will become 4 times 1 is 4 times 9, that's 36. 36 divided by 4, the answer is 9. Therefore, our vertex, the vertex is 0, 9. Okay, we will highlight this one. Next would be the axis of symmetry. Symmetry, so it's x equals to h, and our h is 0. Therefore, our axis of symmetry is 0. X equals 0. Next, let's move on to the x-intercept. In solving the x-intercepts, we all know that we need to let y be equal to 0. And the given equation, it is 0 equals to negative x squared plus 9. Here, we will use our knowledge of finding the roots of x, or find the values of x. So we could transpose positive 9 to the other side. It will become negative x squared equals negative 9. We will turn this x squared into positive by dividing it by negative 1. So it will become x squared equals positive 9. Then we will use the extracting square root method. So extract square root, therefore x equals to positive negative 3. So the x-intercept, there will be two values for x-intercepts here, class. It would be 3, 0, and negative 3, 0. And I want you to highlight this one or box this one, because this is now the answer. Okay. Next, we're going to solve for the y-intercept. In solving the y-intercept, we're going to let x be equal to 0. So copying the given, y equals to negative x squared plus 9. So it will become y equals to negative, change x to 0, plus 9. And since negative 0 squared is 0, we'll just get directly the answer, which is 9. Therefore, our y-intercept here is 0, 9. And box that final answer. Okay, now let's move on to the table of values. So here our x and y. Okay, in this part we're going to have here, we need to reach for the x-intercept, which is 3, 3, 0, and negative 3, 0. So we need to reach that one. So we will start with negative 3, negative 2, negative 1, 0, 1, 2, and 3. We have here like this because there are two values of our x-intercepts. So we will have it like this. Box that one, put a table, create a table. Don't be lazy, so you need to create a table even if there's grid lines on your graphing paper or your graphing notebook. And we already solved 0. If our x is 0, our y or our vertex is 9. So we will put it here 9. I will give you a hint, class. So since the parabola is symmetrical, meaning the values of negative 1 and 1 are the same. Okay? The values for negative 2 and 2 are the same. The values for negative 3 and 3 are the same. Therefore, you don't need to solve the other 3 tables because you'll just solve the first 3 so that you could get also the values of this part here. So what we're going to do, we'll just solve the 3 first. So if x is negative 3, if x is negative 2, and if x is negative 2, y equals to negative x squared plus 9, y equals to negative 2 squared plus 9, y equals to negative times positive 4 plus 9, so it will become y equals to positive 5. And since they are symmetrical, we'll put it 5. And since negative 2 and 2 are symmetrical, means they have the same value, so we will put 5 also here. Next, if x equals to negative 1, so y equals to negative 1 squared plus 9, so y equals to negative 1 plus 9, y equals to 8. So if our y is 8, if our x is negative 1, so put 1 here or 8 here to below 1, negative 1. And since negative 1 and 1 is symmetrical, we will put also 8 on 1. Therefore, we could proceed to the graphing. Now let us proceed to the graphing of the parabola. So with the help of the table of values, my table of values looks like that. So let's proceed. So we'll start with negative 3, 0. So negative 3, 0 is in this part. I need to change the color of my pen. Negative 3, 0 is in this part. Okay, and label it properly, negative 3, 0. Next, negative 2, 5, negative 2, 5. So I suppose it founds in this part. So proper labeling, negative 2, 5. Next, negative 1, 8. Negative 1, 8 is in this part. Negative 1, 8. Next, 0, 9. 09 is here. So 09 proper labeling is very important. 1 and 8. This is 1 and 8. Next one would be 2, 5. Here, this is 2, 5. And lastly, 3, 0. 3, 0 is in this part. 3, 0. After plotting all the points, class, we need to connect all of them using the graph, using the parabola. So we're going to graph now and connect all the points. Okay. Please bear with my parabola, but I know you can make better parabola than me. So make sure it is accurate as possible. Okay, so this is now our parabola. And don't forget to write arrowheads in both ends. Okay, arrowheads in both ends. Next, we could now identify our maximum point. Why maximum point only? Because since our parabola opens downward, there's no minimum point. So our maximum point is found on the highest peak. So here, so our parabola, the maximum point of our parabola is 0, 9. And box that final answer. And that's it. That would be the end of my discussion for today, grade 9 math learners. I hope you learned something and you are now ready to proceed to the formative assessment. Thank you and keep safe always.